Welcome back, friends. I am so glad to have you here with us as we continue our journey into the world of Bitcoin. We've already met the amazing Hasher and Sigy in the previous episodes of our Bitcoin Tech Tales series, and now it's time to dive into the final step of Jane's transaction. So we're back in Jane's wallet. The wallet has already filled the transaction container. On the left side of the box, she placed coupons with information on where to find the certificates that fund this transaction. On the right, we see the newly created certificates for Tom and the change for Jane. For simplicity, we assumed that Jane's wallet manages only one Bitcoin address. Therefore, both certificates selected for funding the payment have the same Bitcoin address. In the next step, Jane's wallet creates the digital signature of all input coupons and output certificates, confirming her will to send Tom satoshis. The wallet takes coupons from the left side and certificates from the right and makes a hash in the first step. Then, it plugs the private key and the hash into Sigy to create the digital signature. The wallet saves the signature and the public key in the witness box in the last step. The digital signature and public key express her will to send satoshis to Tom. But not only. They also prove ownership of the certificates she wants to use for payments. So, how is this possible? Let's look closely at the certificates she used for payment. We see the condition stating that the owner must prove the ownership of the provided Bitcoin address. In our case, this is Jane's Bitcoin address. Jane's wallet uses the same private key to calculate her public key, Bitcoin address, and digital signatures. You can always calculate Jane's Bitcoin address from her public key. Therefore, Jane's digital signature and public key prove that Jane owns the certificates. This concept makes it possible to verify ownership of satoshis without personally knowing the private key owner. Therefore, Bitcoin does not need an intermediary for its transactions, only the algorithms. They treat all transactions equally, without exception. We will explain later how algorithms verify the transactions. You now understand that only the private key makes payments possible. Again, do not share it with anyone and please keep it safe. The wallet has finished Jane's payment. Next, it creates the ID of the transaction and witness box, which is the hash of each. In this way, the Bitcoin network can identify them, and, at the same time, check if hacker modified their data after they left the wallet. The message with the payment transaction data, also called Bitcoin transaction, is now ready to go. After the wallet completed the transaction, Jane received the transaction details and the request to send the transaction in her app. She confirms her will to send the transaction. Therefore, the wallet forwards the transaction to the Bitcoin network. With the creation of the witness data, the wallet completed Jane's transaction to pay Tom. The witness data proved that Jane is the rightful owner of the funds and shows her will to send her satoshis to Tom. Jane's transaction is now making its way to the Bitcoin network. In the following episode of the Bitcoin Tech Tales series, we'll examine the Bitcoin network and all the magic behind the scenes. So make sure to join us. See you.